Hello, today we'll be presenting about the fundamental of wave, and let's start with the concept of wave, which is what is wave. So a wave is a disturbance that transfers energy through vibration or oscillation from one place to another without transferring matter. And one thing that I want to clarify is the progression wave is a wave that travels continuously in a medium and in the same direction without changing its amplitude. And one vocabulary that is very important and essential in the study of wave is the word propagation, which is the direction that wave travel. So wave can be divided into two types, which is electromagnetic wave, which is a wave that can travel through the vacuum, for example UV ray, gamma ray, or radio wave. Other is mechanical wave, which is wave that require medium to travel through, which can be divided into two different types depending on how does it move. So the first one is longitudinal wave, which is a wave that the oscillation are parallel to the direction of the propagation. And the wave are like this. It has region like this and like this and like this. The second one here is the compression, is where particles are compact together, and this space here region are called rarefaction, which is the region where particles are spread out. An example of this type of wave is sound wave and seismic wave. Other type is transverse wave, which is wave that the oscillation are perpendicular to the direction of the propagation. An example of this type of wave is wave on string or the surface water wave. Now let's move to the property of wave. Let me draw a wave here. So this point here, this line here is called equilibrium. And the highest point of wave is called the crest. The lowest point of wave is called trough. The distance between two crests or the two consecutive crests or trough is called wavelength. And here space between the equilibrium and the crest or the trough is called amplitude, which is the maximum displacement from the equilibrium position, measuring the wave strength. Amplitude. And the period is the time taken for one complete cycle. One complete cycle is like from here to here is one complete cycle, or from here to here is one complete cycle. And it can be calculated by using its formula T equal 1 over the frequency. And what is frequency? If you're asked, the frequency is the number of cycle per second, and it's measured in hertz. And we use the formula F equal 1 over T. Example calculating using this, if you want to find the period and you got the frequency of 2 hertz, so we use this 1 over 2 hertz. It is 0.5, which can be translated to 0.5 second, as period is the time taken for one complete cycle. And for the frequency, it is if you got like 0.5 period, you use 1 divided by 0.5, you will get the frequency of 2 hertz. Next is about the wave speed, is the speed that wave travel through medium, and it can be calculated by using the formula V equals F, which is frequency times the wavelength. And example of this is the frequency is 2 hertz and the wavelength is 10 meters. You'll get the velocity of 20 meters per second.
Next is the analysis of wave propagation. Wave propagation can be analyzed through the ray and wavefront. Ray are the straight line that represent the direction of wave, and wavefront are the curved surface of constant phase that represent the oscillation within the wave. As you can see, here's the wavefront, and this the ray releasing from the source. The ray and the wavefront are perpendicular, and if we use these two components, we can use it to see the progression and direction of which the waves are traveling. Next is 3 types of wave optics. The first one is refraction. Refraction is a change in direction of wavefront that occurs when a wave enters the boundary that bounces it back. As you can see in the diagram, the incident ray hit the mirror and bounced it back at the same angle, causing the angle of incidence and reflected angle to be the same. This also refers to the law of refraction that I equal R, angle of incidence is equal to reflected angle. The next one is diffraction. Diffraction is the bending of wave around object when passing an obstacle. As you can see in the diagram, there's the wave and this is the obstacle. As the wave passed through the obstacle or the gaps, the wave was diffracted or bended. To increase the diffraction of the wave, we can either increase the length of the wave or narrow the gaps. This will both increase the diffraction.
Next up is the refraction of waves, which occurs when a wave changes direction due to a change in speed as it passes through the boundary of different mediums. I'll be talking mostly about light refraction. So over here, this is the boundary, this is the normal, and you can see the light bending over here as it passes through the medium. This is the incident ray and this is the refracted ray. This is the angle of incidence and this is the angle of refraction. As you can see here, as light goes from a less dense medium to a denser medium, the angle of refraction will bend towards the normal. However, if light goes to a less dense medium, then the angle of refraction will bend away from the normal. How much a light bends can be quantified by the refractive index of each medium, which is this formula over here, where n is the refractive index, c is the speed of light in a vacuum, and v is the speed of light in the medium. This is Snell's law, which is this formula over here. An example question is light moving from air to water at an angle of 30 degrees. So n1 would be the refractive index of air, which is 1. N2 will be the refractive index of water, which is 1.33, and the angle of incidence will be 30 degrees. So just plug that into the formula and we can solve for the angle of refraction, which is 22 degrees. When light moves from a denser medium to a less dense medium, sometimes the angle of incidence will reach the critical angle. At this critical angle, the angle of refraction will be 90 degrees, causing the light to refract and be parallel to the boundary. If the angle of incidence is greater than the critical angle, then the light ray will cause total internal reflection instead, as seen here. This is the formula for finding the critical angle. As you can see in this example, as light moves from water to air, the N2 will be the refractive index of air, which is 1, and 1 will be the refractive index of water, which is 1.33. And you can solve for the angle of the critical angle, which is 48.6 degrees.